For Ohm's law, you need to understand V is equal to I times R. So very common law we use for DC circuits. Let's try to understand a little bit about this law in detail, and then we will do past paper questions about Ohm's law. First thing about Ohm's law you need to understand is that imagine that we have one cell and there is a one resistor that is connected in series with this battery. So this is resistor. Let's say EMF of this power supply. This is simply you can imagine this is a cell. EMF of this cell is E, and potential difference across this resistor, if you need to find out, let's say we need to find the potential difference across this one, so simply we can connect voltmeter. If we connect voltmeter across this resistor and imagine that the resistance of this resistor is capital R and current in this circuit is I. Now we can use Ohm's law and we can find out value of V. If we know how much current is passing through this resistor and what is resistance of this resistor, then we can find out what is potential difference across this resistor using Ohm's law. So this is what is use of Ohm's law. So this one is the PD. So we can say this is the potential difference across the resistor. So we can say this is PD across resistor, or any other component is not only resistor, so it can be across any component. And the second thing, I is current passing through resistor, so that is the current that is passing through resistor, and R is the resistance of that component, or in this case we are talking about resistor, so this is resistance of resistor. So this is what is Ohm's law. Let's try to understand a little bit about power as well. P is equal to VI. P is equal to VI. And from here, if I want to replace, let's say V, I can replace this one using Ohm's law. So we can say V is equal to I times R. So we can write down power in a different form. So we can replace with IR. And this is multiplied by I. So you can get another formula for power, that is I squared times R. We can also replace I here, and we can use for I, we can write down I is equal to V by R. So we can replace I. So we can get a different formula for power. So we can replace I with V by R. So this is V by R. So we will get formula that is V square divided by R. So you can see in this case we have three different formulae for power. So you can calculate power using this formula. You can also calculate power using this one. It depends what is given to you in question. You can also calculate power using this formula. Now how we can remember all of them? The one way to remember is this small chart you can see here. For example, if you need to find the resistance, so this part is for resistance. So you can see this quadrant. If you need to find resistance, you can use these three different formulae based on what is given in the question. So you can calculate resistance based on this formula. You can also calculate resistance is equal to this one, and you can also calculate this one to calculate resistance. So this is also equal to resistance. And the second thing you need to understand, if you need to find power, so you can use this formula here, or you can use this one, or you can use this one. So any formula you can use depending on what is given to you in the question. So this is how you can calculate power. For power you have three different formulas. If you need to calculate value of current, we can use these three formulae. You can use V by R, you can use P by V, or you can use P divided by R. You can use this one. So you can use any formulae and you can find value of current. Now the next one, let's say you need to find value of voltage, means the potential difference. You can use this formula. You can calculate potential difference, or you can use this, or simply you can use V is equal to IR, and this is Ohm's law. So any one formula you can use depending on what is given to you in the question. So you see these four different quantities. You can use three formulae for each of them. So this is one way to remember this one for power. So these quantities you can calculate using this small table. Now let's go to next one now. Now in today's class, as I mentioned before, we will only focus on this formula. We will only discuss what is Ohm's law and how to use Ohm's law in different circuits. So let's go to next one and try to solve some past paper questions. So here is the first question. So I hope you will try first of all by yourself and you will try to answer, and then I will explain you the answer. Means I will show you the answer, then I will explain. So can you please try to answer question 1? Question 1, please try to answer first of all by yourself. Question 1, please try first of all by yourself. You have 2 minutes. You can try to answer this one. Okay, first of all, please try by yourself. You need to understand conventional current and you need to understand flow of electrons. So you need to understand direction of each of them. Conventional current and flow of electrons. You have 1 minute. You can try. Then I will show you the answer and then we will discuss. Okay, so let me give you some hints. For conventional current, you need to understand current flow from positive terminal to negative terminal. And flow of electrons, you need to understand electrons flow from negative terminal of the battery to positive terminal of the battery. So this is the hint you have to use this. Okay, so answer for this question, I hope you have figured out by yourself. Answer for this question has to be B. B has to be the answer. So this one is the right answer. Now let me explain to you how we got this answer. For this question, first thing you need to understand, conventional current will flow from positive terminal of the cell to the negative terminal. So it will flow in this circuit like this. So this is direction of conventional current. So this is how conventional current will flow. So we can say this one is conventional current. So simply we can write down this is conventional current. So this is direction of conventional current. Now the second thing we need to understand is flow of electrons. Electrons flow from negative to positive, means from negative terminal of the cell to positive terminal of the cell. So electrons will flow in this direction. So I will draw inside this one. So this is how electrons, they will flow from negative to positive. So this is flow of electrons. So this is flow of electrons. So this is how electrons will flow. So this is you need to understand about conventional current, and also you need to understand about flow of electrons. Now let's see why A is not right. If you look at direction of conventional current, this one is right. But how about flow of electron? This direction is wrong. This one is wrong. It has to be this way. So that's the reason A is not answer. If you look at C, direction of current, this one is wrong. It has to be down. So this one is wrong. Flow of electrons, this is also wrong because it has to be down this way. So this one is also wrong. That's the reason C is not answer. If you look at option D, you can see direction of flow of electrons. This one is right from negative terminal. So this one is right. How about conventional current? This one is wrong because this one has to be down. So that's the reason D is also not answer. I hope this one is clear to you. What is conventional current and what is flow of electrons? Let's move on to next one. We are discussing some very nice questions. So always do question first of all by yourself, and then you can check your answer with my answer, and then I will explain. So please do this question. You have 2 minutes. Take time. Read question carefully. If you need hints, you can speak out. You can ask me. Okay. So answer for this question has to be C. So let me show you the answer. This one is the answer, please. If you have figured out this answer, wonderful. If not, now listen my explanation, please. So let me explain to you why we got this answer. For this one, you need to understand it is given to you the voltmeter reading is 2.2. So voltmeter reading is given. So this is the first thing you need to understand. Voltmeter reading is given, that is 2.2. And current passing through ammeter is also given, that is 0.25. So it means this reading is given to you, that is 2.2 volts. And this reading is given on this ammeter, that is 0.25 amps. Now we have two resistors. We have potential difference across them and we have current passing through them. So simply you can use Ohm's law. So this is direct use of Ohm's law. So we can use Ohm's law. So in this case, you will find the total resistance of two resistors. Means the total potential difference across them and current passing through them. So simply in this case, we can write down R total will be equal to V divided by I, and V in this case is equal to 2.2 volts. And you will divide this one by 0.25 amps. So the final answer in this case you will get that will be equal to 8.8 ohms. So this will be the final answer. So this is the total resistance, not the final answer. Actually, final answer only for total resistance. So you have got total resistance. Now you need to find out resistance of each resistor. We have two resistors. It means 2R. This is equal to 8.8. So from here we can find out R will be equal to 4.4 ohms. So this is the value of R. This is how you can calculate. So that's the reason answer for this question is 4.4. So Ohm's law, you need to understand, V is the potential difference across those components or across that single component. And I is current passing through those components or through single component. And you can find the answer. I hope this one is clear to you. So the answer for this question is C. Let's move on to next one. And other nice question, conceptual question. You don't need a lot of calculations, but you need to understand the concept. So please try this one first of all by yourself. Okay, so let me explain to you. If you have figured out, is wonderful. If not, so let me show you the answer first. Answer for this question has to be C. So why C is the answer? Now let me explain. First thing you need to understand, it is given to you each lamp is labeled 240 volts. Normal brightness. If you're talking about normal brightness, it means what is written on the bulb. That much voltage you have to give to the bulb. Mean that much potential difference has to be across that light bulb. Let's say I have a light bulb that is 240 volts. So potential difference needed for this one for normal brightness so is 240 volts. If you give this much potential difference, this, let's say we connect a power supply here, and if potential difference across terminals of this power supply that is equal to 240 volts, we are assuming in this case it has no internal resistance. So it means if I connect voltmeter here, reading on this voltmeter across this bulb, that also will be equal to 240 volts. So in this case, this lamp, the brightness of this one will be normal. So it will have normal brightness. So it will have normal brightness. If we give the potential difference that is written on the bulb, let's say we have this is 240 volts bulb and the power of this one is written on this one is 60 watt. It means that if you give this much voltage, potential difference across this one, the power of this light bulb that will be 60 watt, and then we will say this is normal brightness of that bulb. So this is how you need to answer this problem. So it means all these bulbs, they have to be connected in parallel. So the potential difference across each of them is equal to 240. So you can see this is just one wire. It means potential anywhere at any point on this wire is equal to 240. And here this one will be 0. So you see the potential difference between these two wires are across any light bulb. If I connect light bulb here, means voltmeter across this light bulb, reading on this one will be 240 volts. Anywhere you connect, reading will be the same because they are connected between two same points. And the difference between these 2 points, potential difference is equal to 240. So the answer has to be this one. So these lamps, they are connected in parallel. So we will say they are connected in parallel. Okay, let's move on to next now. I hope this one is clear to you. If you have any questions, you can speak out. If you will not speak out, my assumption is that my class understand what I'm saying. Okay, let's move on to next. Okay, look at this now. Very nice question, conceptual question. So please try to answer this first of all by yourself. Okay, so let me show you the answer and then I will explain. Answer for this question has to be B. So let me explain to you why answer is B. This question is asking you which statement about readings on the ammeter is correct. Readings on ammeter. So we have ammeter P here, we have ammeter Q, and we have ammeter R. So in this case, first thing you need to understand, let's say current I is coming from this battery. Let's say this is current I. I can say this is I naught. At this junction, you will see this current will split into two parts. Let's say current passing through Q, this is I1, and current passing through this resistor, let's say that is I2. At this junction, you will see current coming from here, that one will be I1, and current entering from this side this one will be I2. Now if I ask you what is current here, you will say this one is I1 plus I2. But I1 plus I2, this is equal to I naught. What does it mean? It means that reading on this ammeter and reading on this ammeter, it will be the same. Simply you need to understand current leaving a battery always equal to current entering the battery. So from here simply we can conclude that IP means the reading on this ammeter. This one will be equal to I times R. But if you compare with Q, for example, so if I compare P with Q, so current in P will be greater than current in Q, and also the current in R, it will be greater than current in Q. So these 3 points you need. If you have figured out these points, it simply means that you can figure out the answer. So answer for this one has to be B, because current in P is the same as current in R. Means the reading on ammeter P is equal to reading on ammeter R. So this is our answer. Now if you look at option A, is given to you is equal to the reading on Q, but the reading on Q P is greater than reading on Q. You can see here the reading on P is greater than reading on Q. So it means A is not right answer. Equal to, if it was written greater, then this can be right answer, but it is written equal, so this one is wrong. If we go to C, is given to you reading on Q is greater than reading on P, that the reading on P is greater than Q. So this is the point. Again, we need to use this one. So this one is wrong. Greater, this is wrong. If it was smaller, then this can be right. So C is not answer. Reading on Q is greater than R, that is also wrong, because reading on R is greater than reading on Q. So this is greater. It has to be smaller. If it was smaller, then it is right. So the answer for this question is B. I hope this is clear to you. So this is how you can approach this type of problems. Let's move on to next one. Another nice question we will discuss. This question needs some calculations, but this is very straightforward question. Simple use of Ohm's law. So please try first of all by yourself. If you need any hints, you can speak out. Otherwise, try by yourself and try to figure out answer. Okay, so let me show you the answer now. If you have understanding, you should have done this question. Answer for this one is C. Now let's try to understand why answer is C. For this one, first thing you need to understand, terminal potential difference of this battery is 6.0 volt, or you can say the EMF of this one is equal to 6.0 volts, because we are assuming it has no internal resistance. Internal resistance is not part of IGCSE, so each cell will be ideal cell at IGCSE level, so you no need to worry about internal resistance. Now in this case, if we connect voltmeter across this one, because we need to find out current passing through 8 ohm resistor. So if we connect voltmeter here, this is the first thing you need to understand. Imagine that we connect voltmeter at this point. So what will be the reading on this one? You can see as this is connected in parallel with this cell, so the reading on this one also has to be equal to 6.0 volts. Now we have resistance of this one, we have potential difference across this one, then simply you can say, you can use Ohm's law. You can say V is equal to I times R. So in this case, we need to figure out I. So this is simply equal to V divided by R. So you will see we will be using Ohm's law in all these DC circuits. In all these circuits, we will simply use Ohm's law. So importance of Ohm's law, you need to understand, is very useful at IGCSE level. So you will see a lot of questions about this. So in this case, we have potential difference that is 6.0 volts, and resistance of this one is equal to 8.0 ohms. So we can figure out value of current. That will be equal to 3 by 4, or simply in decimal form, we can say 0.75 amps. So the answer for this question is C. Okay, I hope this one is clear to you. Just simply you need to use Ohm's law. Let's move on to next problem. Here another question about normal brightness. So we have done similar type of question before. Now I hope you can answer this one by just looking at this problem. I have explained you this part. I have explained you this one. So if we want this much power out of the light bulb, how much voltage we need to supply? we need to supply this much voltage, 230 volts we need to apply across the light bulb for normal brightness. So these are the key points you need to understand. So now please try to figure out answer. Let me show you the answer. I hope you will say answer for this question is B. B is the right answer. Simply you need to understand these resistors, these light bulbs, they have to be connected in parallel with power supply because we need this much voltage across each light bulb. So this is the only possible answer. If I connect voltmeter anywhere, let's say if I connect voltmeter across this light bulb, reading on this one will be 230 volts. If I connect voltmeter, for example, here, reading on this one also will be 230 volts because these bulbs, they are connected in parallel with the power supply. So the answer for this one is B. This is not right because in this case, potential difference, if I connect voltmeter here, for example, let's say this voltmeter is V1 and let's say this voltmeter is V2 and we connect this one across the second light bulb. You can also understand in this case, potential difference will be divided into two parts. Voltage will be divided into two parts. So the potential difference across this one will be equal to 115 volts and across this one also will be 115 volts. As this is less than required, so the brightness of this one will be lower, means these bulb, they will be dimmer than actual one. So they will be dimmer. So it's not possible. In this case also potential difference will be lower across each bulb. So also these bulbs, they will be dimmer because potential difference across them will be low. And they will be the dimmest because potential voltage will be divided into four parts. So they will be very dim. So we will say very dim. Look at this question and try to answer first of all by yourself. You have 1 minute. You can try to answer and then I will explain. You need to connect voltmeter to measure potential difference across a resistor. So which one is right answer? Okay, I hope for this question you will simply say answer has to be B. This one is the right answer. So now let me explain to you why other answers are not right. If you look at this one, this is measuring potential difference across the light bulb. We have to measure across resistor. So it means this is connected at wrong place. If you look at this one, so this voltmeter is connected wrong. This has to be in parallel to this resistor. So this one is wrong. If you look at this one, ammeter, this voltmeter is connected across this cell, is not across this one. So this is also wrong. It has to be here. And this one is the only right answer. Let's move on to next one. Very nice question. So please try to answer by yourself. Spend some time and try to answer. Answer for this one should be C. Answer for this one is C. So now let me explain to you why this is the answer. Because if you close this switch is closed, one is closed, second is closed, and if you close the third one as well, you will see bell and the lamp, they will be on. Means this one will be on, this one also will be on. If you look at option A, is telling you 1 and 4. So now let's try to understand why this one is wrong, why A is wrong. So I will clean this one and I will close two switch. If I close one, for example, if I close this one and I close this one, in this case light bulb and this bell, they will be off. So this one will be off, no current passing through this branch, and this one also will be off. And so that's the reason this is not answer. If you go to B, maybe some of you will be thinking maybe B is the right answer. So let's check option B now. Second, it's telling you if this one is closed and this one is closed. You see no current is coming from the cell. No current means circuit is not complete. If circuit is not complete, it means, you see, if current is coming from here, for example, current can go this way. But how about current coming from here? This will go this way. Then where current will go? So circuit is not complete. So it means this is not possible answer. Now let's move on to the last one. 1, 3, and 4. So if we close all of them, then what will happen? So very important point. This question has some very nice points to understand. So let's go to the last one. Maybe some of you have questions about that. If I close all these switches, now let's say we close this one, we close this one, and we close this one. So what will happen in this case? You will see this is kind of short circuit now. So current will flow from here and current will just go like this. So this circuit is short circuit now. Your current will flow like this. Very high current, because this is just a wire short circuit. So current takes the least resistance path. Current, this one you need to understand. This point is the important one. Current takes least resistance path. This one, please. Okay, this one. So it means this is also not right answer. So the answer for this question was C. Now look at this question, please, and try to answer this one. Okay, look at this question. First of all, try to answer by yourself, and then I will explain. Maybe this question is the last question for today's class. Lamps can be switched on and off independently. Independently means you can switch on one at a time. One at a time. Independently, one at a time. So which circuit we need to use? Okay, so let me show you the answer for this question should be A. So let me explain to you why this is the answer. If I close this switch, for example, this switch we close, you will see this lamp will be on, this one will be on. Now if I open this switch now and we close this switch, you will see this one will be off and this one will be on. So you can switch independently, you can switch one at a time. So this is one thing you need to understand. So the answer is this one. But if I look at this one now, if we close this switch, these two lamps, they will be on. So these two will be on. Very good practice you need to understand. So both of them, they will be on. So this is one thing you need to understand. Now, so these two will be on, so we cannot switch on independently. Now, if we close this switch, no current will flow. Both of them, they will be off. So no current will flow. And if we close this switch and we close this switch, this is the point you need to understand. In this case, this one will be on, but this one will be off because this is short circuit. So this is short circuit. So this one will be off. So this one will be off. Short circuit. So this is ideal wire. It has no resistance. So this will be off. And in this case, if we close this one, this lamp will be on. This one will be on. So this one is possible. This will be on. But if we close this switch, this one will not be on. This will be off. But if we close both of them, this one will be on and this one also will be on. So we cannot switch them on independently. So this is also not possible. And for this one, simply you will say, if I close this switch, this will be off. So this will be off. And this one also will be off. But if I close both switches here now, so you will see these two light bulbs, they will be on. So this one will be on and this one also will be on. So we cannot switch them on and off independently. So this is also not possible answer. So that's all for today's class. I hope you have some better understanding of this topic, and I'll see you in next class with potential divider. We will discuss more DC circuit problems in next class. Bye for now. See you in next class.